station, this is Houston. Are you ready for the event?
Station's ready.
Houston ACR, this is Mission Control Houston. Please call station for a voice check.
Station, this is Houston ACR. How do you hear me?
Station has you loud and clear.
Please stand by for opening remarks.
I'm Sherrod Brown. It's a privilege to serve the people of Ohio in the United States Senate. Welcome to the students, the educators, and just simply space lovers tuning in from Ohio and across the world for today's Downlink Q&A. Ohio has always been a leader in aerospace and aviation. From the Wright brothers to John Glenn, from our aerospace companies in Dayton to the cutting-edge research at NASA Glenn, scientists, researchers, engineers across the whole state. We are an aerospace state, make this work possible. Thanks for tuning in today. Thank you for celebrating our nation's amazing advancements in space.
Hi, my name is Alex Light from Emerald King Elementary, Roraine, Ohio. My question is, when training to go to space, what activities do you have to do to prepare yourself?
Hi, Alex. So when we're training to go to space, we spend about 2 years initially in what's called ASCAN, or astronaut candidate training, where we do a series of training to get us ready for kind of any mission and to get ready for the space station. And then once you're assigned, you do more specific training for whatever that expedition or mission will be. So Tom and I came up here on the Crew 3 mission and are on Expedition 66. So a lot of our training was specific to the science on board. In terms of training during ASCAN, there's 5 major parts. There's robotics training. We learn Russian because part of the space station is Russian, so to be able to work with them, we learn how to speak Russian. We also do training in spacewalks, or EVAs. We do a lot of training on the International Space Station systems to learn how to fix it and operate it. And then we also do training in the T-38, which is an airplane that we use to work on what we call space resource management. When we work as crews in the airplane, it's very similar to how we work as crews in space.
Hi, my name is Imani, and I'm from the Cleveland School of Science and Medicine in Ohio, and my question is that if you had to live on the space station for the rest of your life, what 3 items would you take with you?
Hi, Marty. Boy, that's a tough question to answer. However, I assume you mean I can't bring my family. Now, they might not want to come live with me for the rest of our lives on the space station, but if I couldn't bring my family, I would probably bring, we have so much stuff that's wonderful here with science. I would bring things like probably a paint set. I would bring a library, whether that's a Kindle with all the greatest literature that I could find. I'd have a lot of time to read. That'd be good. And I'd probably bring a musical instrument to let my creative side grow. So that would probably be it.
Hi, my name is Jemiah. Here's my question. My team has been really interested in how fluid behave in space. Can you demonstrate how water behaves and explain why?
Yeah, sure, Jemiah. So one of the really cool things about water in forces in general, so on Earth, there's always different forces acting on things, and gravity often is the dominant one. Here in space, there's microgravity, and so you can see here the dominant force is surface tension. So it turns out water molecules really like to stick together. And so instead of falling or dispersing like they do on Earth, they stick to things. So whether that's my hand or whether that's the straw, it's both fun and interesting. And the reason it's interesting is not only does water behave differently in space, but a whole lot of different materials and molecules behave differently in space when the forces that govern them aren't always dominated by gravity. And so that helps us discover new materials and new ways of making materials. And so water oftentimes is a really good analog for us to look at to understand with a very simple non-toxic substance before we do more complicated experiments with things that are maybe a little more dangerous or have to be contained a little bit more carefully.
Hello, my name is Fernanda from the Ike Primary School in Akron, Ohio. How do you analyze data from the space station?
Well, there certainly is a lot of data come from the space station, both on the health of the space station and all the scientific data we're putting down. So the way we do it is we have big antennas on the space station. We downlink, so we have to have good communication. We probably bounce it off a satellite and get it down to all the mission controls around the world and all the scientists around the world. And so they collect that data. And it's really nice to know that Mission Control is down there watching the health and status of the space station, because they're watching us every minute of every day, 24 hours a day, 365 days a year, to make sure that the space station is healthy, they're keeping us alive and keeping the mission going.
Hi, my name is Mia. I'm from Parma Community Middle in Parma, Ohio. My question is, what is the most interesting experience you've had in space? Thank you.
Hi, Mia. I think for me the most interesting thing was helping Tom and Kayla go do a spacewalk. And so earlier in our mission, they went out to fix what's called an S-band antenna, which is one of the antennas, as Tom mentioned, that we use to transmit data back and forth to the ground. And so they went out to replace that antenna. As part of that, Matthias and I and Mark, the other three crew members up here on the U.S. segment, had to suit them up and then send them out the airlock, which is pretty cool to put your friend into a spacesuit and then send them outside into space. And then once they're out there, what was even better is we got to move Tom around on the robotic arm. And so we practice and train a lot for that on the ground, but actually having your friend be out there on the end of an arm you're moving in space was a pretty amazing experience.
I am Sebastian Gilchrist-Haya from Horizon Denison Science Academy in Cleveland, Ohio, and I want to ask, how do you get fresh water to drink in outer space, and how do you specifically stay clean?
Hey, Sebastian. Well, I tell you, we can fly water up to the space station, but water is actually pretty heavy. We want to reclaim as much as we can so we can use all that space on the spaceships that come to us for scientific equipment and food and those kinds of things. So we reclaim the water that comes out of our bodies, and it may come out as sweat, and maybe the water that comes out when we go to the bathroom. But we have these wonderful purifiers that clean that water, and we can get about 93% of the water reclaimed, which is actually a wonderful thing and essential before we go to Mars, because we're going to need about 98% reclamation rate in order to be able to go to Mars, so we don't have to carry too much water with us. The way we stay clean is we use wet wipes. We don't have running water up here. We can't take showers or baths like you might think, but it's actually pretty nice. We have just gauze towels or thick towels that we wet and then rub all over ourselves with a little bit of soap and then do it again to get the soap off. And that's how we stay clean.
My name is Jacques Cameron. I'm from Ginn Academy in Cleveland, Ohio. My question is, as an astronaut, what is your favorite thing to do in your free time?
Well, one of the things is just getting around. And so the ability to just float and move around with just fingertips and slight pushes and fly through modules, kind of like feeling like Superman shooting through things, is pretty fun. And that's just getting around from task to task. But really my favorite thing to do in my free time is to go look out the window. So we have what's called the cupola, which is both a window that we use for when we're running the robotic arm, but also gives us a great opportunity to look outside and see the Earth below us, see the city lights at night, see the oceans, and see the cities and countries during the day. So it's a pretty amazing view, and that's definitely my favorite thing to do when I've got free time.
I like to dance. Can you dance in the ISS in space?
Hi, Tracy. I think it would be fun to have more dancing up here. We do a little bit of it. We do play music up here. So we'll demonstrate something that's not exactly a dance, but it kind of looks like it. And this is a way that you can demonstrate angular momentum. It's the way a cat turns. If you ever wonder how a cat can always land on its feet, this is how it does it. Excuse me.
So that's some serious hip shaking going on.
Hi, my name is Ali. We heard most of the food you eat is dehydrated to save space and reduce launch weight. Here's my question. How do you prepare food in space, and do you have a favorite?
So, Ali, we have a few different ways to prepare and store food up here. So we have both freezers and heaters. We use the freezers mostly for science, but we can also use them for food. So we got special delivery of some popsicles with our last Cygnus cargo vehicle. Once the food's up here, then we prepare it a few different ways. So we have kind of traditional dehydrated food, and so that's cashew chicken curry, but without any water in it. And so basically we hook it up to a water dispenser, we add the water back in, and then after about 5 or 10 minutes of letting the water soak in and keeping it in a heater, then it's ready to eat. The other type of food we have is prepackaged, so it's not dehydrated. Those are candy-coated chocolates, and so basically those are just like you would have on Earth. So there's some food that if it's not perishable, not stuff that will go bad, you can just fly it up packaged, and we're able to eat it here. This stays in the bag, though, but as you can see, it'd be pretty hard to control all those little guys once they get out of the bag, so you got to be ready to eat them when they come out. The other thing that we do is actually grow our own plants. And so while we've been up here, we got to eat some hatch chilies that the previous expedition grew, and then we started growing some lettuce. And the reason we're doing that is not only because it's great and delicious, but really we're also researching that for our eventual return to the moon and to stay on the moon and go to Mars. We'll be able to, we need to be able to grow our own plants. We can't haul it all with us. Just like water, it's really heavy to bring all that stuff with us. So we're working on the technologies that we need to be able to grow sustainable food for astronauts and for future humans on other planets.
My name is Cameron, and I am from Parma Community Middle School in Parma, Ohio. My question is, what has been your favorite experiment on the International Space Station?
That's a really hard question to answer. They're all extremely exciting, and we're very honored to be a part of them. The most recent one I worked on, which I thought was very interesting, was I was taking skin cells, human skin cells, that had been grown in a petri dish, and they flew them up here in these little pellets, and they were looking at the effects of the radiation of space and the zero-G effects on skin cells. And it turns out that being in space tends to age our bodies faster, much, much faster in terms of bone loss, muscle atrophy, effects on the skin. Ages us much faster than it does on the ground. So this is an opportunity to take some human organ, the skin is the largest organ on the human body, and to see what all those effects are. And that way we can come up with ways to help prevent the aging, help prevent the damage to the skin cells, and get the results a lot faster. So that's been a fascinating one to work on.
Hi, my name is Miguel Rivera from Parma Community Middle in Parma, Ohio, and my question is, how do plants grow in space?
Well, Enrique, we have a few different ways we try to grow them up here. You can't quite see it, but just off screen here is we call them veggie pillows, and it's essentially plastic bellows with a plate on the bottom, and that lets us control the lighting of the plants. And that particular experiment, we are looking at different ways to deliver water and nutrients to the plants in a less user-intensive way, meaning that it was a passive system, letting the plants absorb their own water. We have another system in the Japanese module, the GEM we call it, that is a much more controlled thing, kind of like a hydroponic system on the Earth, where we're controlling the gas flow and the nutrients and everything into the plants. And so there's a few different methods of doing that, and we're trying to figure out what's the best way and the most time-efficient way, and also things like what's the lightest way and the ones that get the healthiest plants the fastest. So there's a few different ways we do that. The third type of research we're doing on plants and growing is actually growing them at the cellular level. So one of the really cool things about growing cells in space is without gravity, when you grow large, big chunks of cells on the Earth, they get flattened out. But when there's microgravity, they can grow three-dimensionally, and so you can get larger structures to study faster. So we're doing that with cotton plants to try to find cotton that is more drought-resistant to help the Earth, but also to understand how to grow chunks of plant cells in space better.
Hi, my name is Trishelle Edmonds, and I am from Horizon Science Academy, Denison Middle in Cleveland, Ohio. And my question is it hot or cold in outer space?
Hi, Trishelle. That is a great question, and the answer is yes, it's both. It all depends on what part of the object or your body is facing the sun. We have direct UV and all the other types of electromagnetic radiation come from the sun, and it can be 250 degrees Fahrenheit if you're facing the sun. The other side of you, or of the object, is in shadow, and that can be negative 250 degrees Fahrenheit. We can actually feel that when we're out on a spacewalk. We can feel a little bit of the difference. Of course, the suit is protecting us between the really hot and the really cold, all at the same time.
My name is Trayshawn Weekly, and I am from Ginn Academy in Cleveland, Ohio. My question is, how old do you have to be able to go into space, and how do you eat in space?
So, Trayshawn, there's really no age limit that we know of to come up in space. Usually the people that have come up in the past have already graduated college, and that's kind of a relic of the fact that you have certain requirements to be an astronaut at NASA. But as far as we know scientifically, we don't really have an age limit per se. In terms of what we eat up here, or how we eat very similar to the way you do on the ground, except we have a really long spoon to dig into packages. You don't open the package up, because otherwise food would go everywhere. So we have these really long handle spoons to dig down. And then the other thing that's a little different about eating up here is we track everything we eat. And so every time you have a snack, a drink, food, we log it. And then that way the people on the ground can keep track of exactly what's going into our bodies. Like Tom mentioned, a lot of the science is understanding how our bodies change in space. And so to understand the full equation, you have to know what's going into your body so you can analyze what comes out of your body. And so there's also some studies that Tom and I are a part of where we're actually deliberately choosing different types of food to see if those have different effects than some of the other crew members. So specifically seeing some lycopene and omega-3 and some other types of food and nutrients that they're looking at to see if that stops some of the aging and the damage to the cells that we typically see in the space environment.
Hi, my name is Braylon. The members of our robotic team are learning about the importance of teamwork. My question is, how important is teamwork aboard the International Space Station? And how do crew members train to work effectively together?
You know, teamwork up here is actually it's essential for our survival and essential for getting things done up here. It's just way too complicated for any one person to do it. So teamwork is something we actually train on quite a bit before we fly. And some of the ways we do that is, first of all, we all learn together. We're in classrooms together. We're in simulators together. We learn how each other thinks. We learn how what people like and what they don't like. And that's all very important. You get to really get to know your crewmates. Sometimes they will put us out in an uncomfortable situation, which sometimes is a lot of fun. It might be a survival trip in the mountains, backpacking in the mountains or in the canyons. So we can really get to know ourselves, kind of get to know what our limits are and how we can help each other out. And all this is really important for developing teamwork and a good team culture before we fly.
Hi, my name is Preston Thompson, and I go to the I Promise School in Akron, Ohio. I have questions about sleeping routines, like where do you guys sleep and how gravity works when you sleep?
Hey, Preston. So where we sleep is actually in the floor, the walls, and the ceiling. So actually behind me, our crewmate Matthias, our German astronaut, that's his crew quarters. And so there's one here, and there's 4 in another module, and Tom's going to show you. Basically, he's just going to go into what looks like the ceiling, but up here you can't tell it's a ceiling or not. And inside there, it's about the size of a sleeping bag and a computer, and that's what we use it for, is to sleep, and then also to be able to do things like get work done in the evenings and correspond with people at home. In terms of how gravity works in your sleep, it's kind of the same as it does during the day. So you would tend to float around. Different people like to do different things when they sleep. Some people like to be restrained and to feel very wrapped up. Some people like to float around. One thing that takes your brain some time to get used to is when you're in space the first few days, you always feel like you're falling. So as soon as you close your eyes, you get the sensation that you're still moving and still falling forward. So it's really hard to fall asleep at first because your brain just doesn't want to go to sleep when it feels like it's falling down. So it takes a few days for your brain to adjust to that to be able to sleep normally. But once that happens, it's just personal preference on how tightly you want to be held by. We use bungee cords to hold us down, and it just depends on how tight you want to be held down while you're sleeping.
My name is London Davis. My question is, do you miss your family and can you talk to them from space?
Hi, London. Yeah, we all miss our families quite a bit. And so the good thing is we are able to email them. It's not always as fast as on the ground because we have to bounce off a satellite. We can have video conferences with them and actually see their faces and have a real-time conversation with them, and that's about every week. But very importantly, we can actually make a phone call. We can call them, but they can't call us back. And so those are the 3 best ways, I think, that we can keep in touch with the family. And just about every day we're in touch with our families.
Hi, I'm U.S. Senator Rob Portman. I just wanted to take a moment to celebrate this unique NASA astronaut event taking place at the Glenn Research Center with all of you. To the students, the educators, and our leaders at the Ohio Department of Education who are critical to our robust STEM education here in Ohio, congratulations. Our flourishing STEM programming across the state is one of the reasons the Buckeye State continues to play a leading role in the future of spaceflight. It's always great to see students take advantage of the STEM education opportunities. I know some of you are tuning in from the Great Lakes Science Center, which is a perfect example of Ohio's STEM education in action. I love that center. I love the fact that young people are able to go there and to get hands-on experiences and therefore get more interest and involvement in science. I've even seen an eclipse there. That's where I chose to be for the eclipse, at NASA Glenn and at the center. Anyway, it's my honor to represent all of you in the United States Senate. Best of luck in your future, and hope to get to see you soon back in Ohio.
Thanks very much, Senators, and to all the kids in the schools there. Enjoyed answering your questions, and we'll leave you with a view of our Astro Bees, or robots. Have a good afternoon.
Station, this is Houston ACR. That concludes the event.
Thank you to all participants. Station, we are now resuming operational audio communications.